So I think I left out in question number, I can remember the question. It's with the center of gravity part. Okay. So we have been asked that where is the exact location of the center of mass? So if I give you a detailed expression, it's a cylinder. This is our cylinder, and they have placed the cylinder in a side way so that this bottommost surface is visible here. So you should understand the cylinders are made. So the cylinders are this way. They are placed in such a way that only their circular surface is visible for you. Okay. So when you are just dealing with these sort of questions, at the basic, now they are saying three identical cylinders, each of mass m and radius r, are placed on a rough horizontal surface to be in equilibrium. The coordinate of the center of gravity of the composite of the cylinder in equilibrium is. So you should understand there will be an overall normal reaction exerted on this object, and you should understand that the center of gravity, or as the center of mass, should be in this line of action. If it is somewhere in the other side, this will start to topple. Okay, so just get that extra point. So if you look at here, if you view from this part, you are having only circular faces. Just remember that if there is a circular face, the center of mass would be at the center. The center of mass would be at the center. So we'll be having the center of mass at these locations. Okay. So every time remember, for a circle, the center of mass is exactly at the center. I'll just get you a special point behind this. So let's try to solve this first of all. So from here it is at a distance r. So additionally there's a distance, I think it's r. It's in such a way. So if we connect these center of masses, if I start connecting these center of masses, I would eventually end up with a triangle. Where in a triangle, at the vertex, we are having some masses located. And the important point is, they are saying us three identical cylinders, each of mass m and radius r. So you should understand the mass of everyone are the same. Okay. So again, if I explain you that, if I connect the masses, I'll be having a triangular structure. So the masses are actually, if I just take the system, it's a triangular structure where the masses are present at the vertex of this triangle. Okay. So I'll get up to here. So I think I just came up to this point last class. So now let's find where is the center of mass. So if you look at here, if I consider these two masses, make sure that you're going to have a tick. M and M, the resultant mass is going to be 2M. The resultant mass is going to be 2M. And it's going to be exactly at the center. The ratio is 1:1. Just remember that. We are having equal masses M and M. So the resultant mass is 2M. which is placed somewhere in between these two guys. Since the mass are the same, the ratio is 1:1. Okay, just get that point. And if you look at here, up to here the distance is r. Up to here the distance is r. So this total side is 2r. Similarly, this side is 2r. This side is 2r. So we are actually getting an equilateral triangle. Okay. So the angle will be 60. I'll say why it is important. For now, if I join these two masses, the resultant mass is 2m exactly at the center of between them. Now, we are having a resultant mass 2m and a mass m here. So if I join these two, the resultant of them will be at the center, so not the center, will be in the line of these two. If I draw it in a separate diagram, the 2m, mass m, the resultant would be in this line, but it won't be at the center. Because unlike this, we are having m and 2m. Only if you are having equal masses, it will be at the center. If you are having unequal masses, of course, they are going to adopt 3m. M plus 2m is 3m. But the ratio is opposite of this. I'm having 2m. So it is 2. Here it is 1. 1. The ratio of the distance will be 2:1. The same, did you get that? Did you get that point? I have the mass m. I have the mass 2m. So the length ratio would be 2:1. Not here, okay? It's not 2:1 here. You have to consider from here. 2:1. So just have it as a short note behind this. If I have a mass m1, if I have a mass m2, the centroid center of gravity m1 plus m2 would be at a distance. The ratio of the distance is m1:m2. Okay? m1 is in this side. So just get that extra point behind this. It's really important when you are dealing with centroid gravity questions. Okay? So, now the location of this 3m is important. So you can see that from 2m, it is at a ratio of 1. It is at a ratio of 1:2. Which means, if this length is L, the center of gravity would be 1:1 plus 2 times L. Okay? Yeah, it's actual logic, okay? When you're having two, now if you just take if you start to carry I'm having a larger mass at one corner, a smaller mass at the other corner, you can just feel that if it starts to rotate, from the large mass only it starts to rotate. Because if you are holding somewhere around here, the center of mass is exactly closer to him. So you must give the reaction here. Okay? You are correct, okay? So every time the center of mass would be closer to the larger mass. The general way. So you should understand, if I want to find the position, I'm finding the position from 2m. So the ratio is 1 divided by 1 plus 2 times the entire length L. So if I was finding from simple M, if I was finding from M, it would be 2 over 1 plus 2. Because the corresponding ratio is 2, right? So it is 2 over 1 plus 2 times the entire thing L. So you can note it down here. Location of the center of mass from M1, it is M2 over M1 plus M2 times the length L. Okay. So this is not important because we are finding the location of center of mass from the x-axis. So the axis is this way, where the 2m is located. So from here we have to find it. So it is at a ratio of 1 over 1 plus 2 times the length L. Okay, so I'll be able to hear. Okay, so now let's find this. It's 1 over 1, 3. What is the length L? Now that's why I was saying you that this is R, this is R. The side length became 2R. So every it is 2R is 2R. So I said to you, right, it's an equilateral triangle. The angle is 60. So 2R sine 60 would get you this entire length L. So if I multiply 2R sine 60, 2R sine 60, I'll be having 2 over 3 R root 3 over 2. Which means it will be at a distance R over root 3. From the x-axis, it is at a distance R over root 3. Somewhere around here. It's at a distance R over root 3. What about my x value then? What will be my x value? I found the y value as R over root 3. What will be my corresponding y value? What was the answer? The question is, the y coordinate of the center of gravity is R over root 3. What will be the x value? 2 by 3. Now see here, 1 over 3, it's fine, right? 1 over 1 plus 2 is 1 over 3. The side length is 2R. So 2R sine 60. It's here. So 1 into 2 is 2 over 3 times sine 60 is root 3 over 2. Okay. So the same way, what will be the x value? Now this is the point where I'm actually having the center of gravity. So the y value was R over root 3. What will be the x value then? Just by looking at this, get an idea. Yeah, it's fine. Now I was saying you that equal masses exactly at the center. So it's actually at the center again. This entire thing is 2R. So this will become R. So it's R comma r over root 3. Okay. So did you get this question? So I'll just share the recordings for others also. Now, so let's get an idea. Don't just confuse with the cylinders. The main thing is they have given the sideway view of this, which means I'm having circles. So in a circle, the center of gravity would be at the center. So first of all, I mark what are things I know actually. I know that if there is a circle, center of mass is exactly at the center. So I have at the center. So now forget about the circular parts. If I want to find the center of gravity, the actual structure is like this, where I'm having a triangle, where the vertex we are having equal masses present. So now as you deal with center of gravity question, start connecting masses and find the center of gravity. Okay. Now no need to think deep even. Now see, initially I was forgetting this 2R. After I proceed the basic part, okay, now I want this length L. Then only I thought about this part. Okay. So shall we move to this? I think the paper 10 is done, right? And I forgot to share a PDF as well. Sorry for that. So I think I shared a PDF in WhatsApp. So let's try some questions in that. I'll share the what cute within today inshallah. So just try them. Don't take a photocopy of that because you can see most of the questions are handwritten. So if you take a photocopy, the color would be not that fine. Okay. The section. What was the question? Mm, this PDF is done, right? Structure part. I didn't try the structure parts. So then let's discuss that then. Okay. So, and I went to say some points behind this. Um, anyways, I'll just say it in the next class as well. Just remind me. Now, when you're dealing with center of gravity questions, of course, you are requiring this theory. Other than that, we just teach you a small point. Now, when you're having circular parts, they might get you some questions with that. Now, sometimes they used to say it's a circular ring. And sometimes they might say that it's a circular arc. Okay, so sometimes they might say that it's a circular arc. So we should get an idea how I'm going to try this question. If this is a circular ring, only the mass is present in this location. Only the mass is distributed in this part, in the circumference. Okay? Which means if I just cut from one part, I'll be having only a length. I'll be having only a length. But if I had a sector, I'll be having mass distributed inside of that even. There'll be mass in the interior part as well. Now in here, if you want, you can have your hand inside because this part is empty. Whereas in this, it's like a paper. There is mass here. So the idea is when you are having a ring, consider mass per unit length. Mass per unit length. And when you are having a sector, consider mass per unit area. Then it will be easy, okay? Okay. What I'm saying is, Now when you're dealing with center of gravity question, actually the mass is important. But whenever they just get you only the radius, you don't have an idea what is the mass. So if we consider the mass per unit length as, let's say, P, okay. So if I was considering the mass per unit length as P, the circumference will be 2 pi r, which is actually a length. So when you multiply with the mass per unit length, I'll be having the mass. Again, for mass per unit area, you consider the entire area, pi r squared, then you can multiply with this part. And finally, these cancel off. And I'll get you a question with that. So basically, that's the idea. If you're having rod C1, you can apply. Just see that whether the mass is distributed in an area or a length. From that, you have to get this point. Okay. So just note it down and let's move to the structure then. So it's a prism structure. So we are having a prism. The angle of that is 30. Shall we try the structure in the next class? Because I think two of them are missing here. Because there were some good points behind this. If you look at, if you consider the B part and C part, using the graph you have obtained, you have to just, what would be the graph if the angle of incidence is this much? So when the angle of incidence increase, what would happen? And when the angle of the triangle increase, what would happen? There are some, like a short note even, there are some points in here. I think it will be really important for your structures. So shall we try the question which I have shared with you? Okay, so let's get that question here. So just try the test. I think, yeah, let's say 2, 3 questions here. There is a pendulum which is oscillating. The periodic time is, the periodic time is t. An object is attached to a vertical spring. Is performed a simple harmonic motion between A and B. O is the center of a simple harmonic motion. And C is between OA. If the periodic oscillation is T, time taken to move from O to C. Forget that it's a spring. If you're confused, whenever you're dealing with MCQ parts, even if you're having a spring, unless they ask you with spring constant, what is the elastic energy, if they are dealing with this periodic time, those stuff, you can just try with a pendulum because we are much more familiar with this than a spring. So whatever, I'll explain both the case. Actual theory behind this is we are having a pendulum. It is oscillating back and forth. The periodic time is capital T. So the time taken to reach the amplitude is T by 4. Center is O. Between O and it's between O and A. So A is the A is the point of amplitude. C is the midpoint between O and A. So they're asking you what is the time. So try to find it. The clue is don't think much. Don't need any equations either. You can just look at that and write. Just try me and get the answer for that. We want the time taken to reach this point C. Point C is at the middle. So just think and get an idea. Try to eliminate answers. It will be really easy for you then. Second answer, yeah. Second one is T by 2. Now see here, the time taken to move from O to A is T by 4. Okay. I'm taking a time of T by 4. So if I want to travel from O to C, so if I want to travel for A, first of all, I must pass C and only travel for A. Something like you are moving from a certain place to another place. There's a nearby shop here. Anyways, you have to pass this. And the time taken to reach this event T by 4. So what can you say about the time to reach this place? Will it be smaller than T by 4 or greater than T by 4? The total time taken even T by 4. In the way between I'm passing this shop. So the time taken, would it be greater than T by 4 or less than T by 4? Change inequalities. Would it be greater than T by 4 or less than T by 4? Yeah, it would be smaller. So see, the time taken is T by 4. So it has to be something quite smaller than T by 4. So if you are saying it is T by 2, T by 2 is greater than T by 4. It's like you are traveling here and again you are reaching this place even. You're almost 2 times crossing this shop. So you can't have the answer T by 2. You can cancel that. So any answer greater than T by 4 is eliminated. Okay? T by 8. So you can see that the answer number 1, you can eliminate. You can't have the periodic time anyways. It's wrong. So T by 2, that's again wrong. T by 3, yeah, it is wrong because it's greater. So you can have only answer 4 or 5. And I am pretty sure that you might have get T by 8. What is the reason? T by 8. What is the reason for your answer? Because you are having two small answers. T by 8 and T by 12. It can be any of them. What is the main reason for choosing T by 8? Yeah, O is 2s of OC. So you might get an idea like that. The distance travel is, for 2D, the distance travel is t by 4. So for half a distance, it is t by 8. Even c is at the middle. But you should understand, only if it is traveling with constant velocity, it is fine. Only if it is traveling with constant velocity, this will work. So you know that in a simple harmonic motion, the velocity is changing at every point. And more important, the acceleration is traveling at every point. So that's why the kinematic equation is equal ut plus half at squared. Any of the kinematic equation you can't use here, because the acceleration is changing from point to point. So in mechanics, the main condition you learn, acceleration should be constant for the set of kinematic equation. So you just forget all the kinematic equation when you're dealing with simple harmonic motion, because you have the equation A equal omega squared x and B equals square root of a squared minus x squared. So you're having that set of equation. You have to use them. But of course, it will be really complicated for you. But I said you right. You can't have the answer t by a. It's an important point. So you can cancel that answer as well. Now I'll explain to you the theory behind this. Suppose you want to find the exact answer. The time taken from O to C is, let's say, T1. The time taken from O to C is T1. If the time taken from C to A is T2, what will be the addition of T1 plus T2? What will be the addition of T1 plus T2? If I add the time taken from O to C and C to A, what will be the total time? Anyways, I said the answer from my mouth. The total time is T by 4, okay? I'm adding O to C is T1, C to A is T2. Addition of them, you should get T by 4. Okay? And try to answer for this. In a simple harmonic motion, where is the acceleration maximum? Where is the acceleration maximum? At A, yeah. When you are reaching the amplitude, the acceleration is maximum, velocity is minimum. So, if you are moving towards A, the acceleration vector would be towards the center, right? If you are moving towards A, there will be an acceleration, as you say. Important point is, acceleration is towards the center, which means it is acting like a deceleration. Okay? From O to A, it's like a deceleration. From A to C, actually it is accelerating. So you should understand the acceleration is almost at the P in somewhere in this region. So somewhere around here, the acceleration A value will increase to that amount, a greater amount. We already know it is maximum at A. So somewhere around this distance, the acceleration will increase. And somewhere on here, it's quite smaller than this part. So you can say this takes a shorter time to cover OC because the deceleration is smaller. It takes a shorter time. Whereas from C to A, it's going to take a comparatively longer time. Just same, did you get that point? Because you might get confused with that. Okay. from O to C, it will travel quickly because the acceleration is somewhat small. And from C to A, it will be quite slower than this. So T1 is less than T2. It is taking a smaller time. Like within 1 second, it is here. 2 seconds, it is taking from C to A. So T1 is less than T2.